Hello and welcome, my students, to this recorded session. Today we'll be exploring the derivative of trigonometric functions. Now you might be wondering, what is a derivative? A derivative is the rate of a change of a function at a particular point, and it tells us how fast the function is changing at that point. Trigonometric functions such as sine, cosine, tangent, and their inverse functions are some of the most commonly used functions in mathematics. And in this session, we'll be exploring the rules for finding the derivative of these functions. And we will use these rules to find the derivative of some simple trigonometric functions. And then we will move on to more complicated examples. I encourage you to pause the video whenever you need and have a go at finding the derivative of the problem we will be working on. Then compare your solutions against mine and see how you did. Remember, practice makes perfect. Let's get started. Here in this example, if y equals sine x, you know that sine x is a periodic function. It repeats itself every 360 degrees. And if I want to find the derivative of this function, let's easily take some points like this point here. And I want to find the derivative when x equals 90, because the tangent at this point is parallel to x-axis, so the derivative is 0. And if we are going to take some point before 90, pay attention, like these points here. Here it's a tangent. The derivative, as you see, it's a positive. So the derivative of this point here is 1. And it goes down to reach 0. Then, if we are going to take a point here, this line here, the tangent, makes an obtuse angle with the positive direction of x-axis, so the derivative here is negative at this point, for instance. So, to reaching -1, after that, if you are going to find the derivative at this point here, the derivative at this point, because this tangent is parallel to x-axis, so the derivative is 0. And if you are going to draw a tangent at any point here, so you'll find the derivative will go up to reach 1. I've drawn some tangents just to determine the derivative along the way of sine x. Here the derivative is positive. So you will find the derivative of the function of y equals sine x is equal to another function. You know what is this function? It's a cosine, as you see here. It's not drawn to scale. It's not accurate drawing. Just I'm showing you how can you find the derivative. So if y equals sine x here, so what is dy over dx? Dy over dx equals cosine x. So the derivative of sine x is cosine x. Here in this function, y equals cosine x, and I want to find the derivative of this function. So let's draw some tangents here along the way of the function. So here, if we are going to draw a line here, you will find the tangent here is parallel to x-axis, so the derivative is 0. And if you are going to take a point after this point, you will find the tangent here makes an obtuse angle with the positive direction of x-axis, so the derivative is negative. So we'll go down here. The derivative is negative. And for this point here, if I'm going to draw a tangent here, the derivative is 0 of this function. And here, if we are going to draw a tangent here, because this line is parallel to x-axis, here, this line here. Let's take this point first. So you will find a positive derivative. So the derivative here is positive. Okay. If we are going to draw here this line here, you will find here's the curve of the derivative. Okay, and the derivative at this point is 0. So we'll go down again. And this function is the derivative of y equal cosine x. As you see here, it's the inverse of sine. So the derivative of cosine x is equal to negative sine x. So y prime is negative sine x, or dy over dx equals negative sine x. That's it. If y equals 10x, I want to find dy over dx here. So we can write, instead of 10, we can write sine x over cosine x. Then dy over dx, in this case, we have top and down or up and down. You will find the denominator down multiplied by the derivative of the numerator. You will write cosine x multiplied by the derivative of sine x. You know, the derivative of sine x, as we deduced, is equal to cosine x minus the numerator, which is sine x, the top, multiplied by the derivative of cosine x. The derivative of cosine x, as we deduced, it's negative sine x over cosine squared x. So here, let's tidy it up. Cosine x multiplied by cosine x is equal to cosine squared x, and negative after negative positive, plus sine squared x over cosine squared x. And you know, sine squared theta plus cosine squared theta is 1. So we'll write here in the top 1. And down, we'll write cosine squared x. You know that 1 over cosine squared x, we can write it as sec squared x. So if y equals 10 theta, 10x, the derivative of 10 is sec squared x. That's it. If y equals 10x, find dy over dx. We can write instead of cosine x, we can write instead of that cosine x over sine x. Then we apply the rule of the division, the quotient rule. You know, here in this case, dy over dx is equal to, we have top and down. We can say u over v, a function divided by another function. So write v multiplied by u prime minus u multiplied by v prime over u squared. That is the rule of the quotient rule. So here dy over dx, we'll write sine x, the denominator, multiplied by the derivative of cosine x. The derivative of cosine x is equal to negative sine x, plus, right, the top as it, cosine x, multiplied by the derivative of sine x. The derivative of sine x is cosine x, all divided by the square of the denominator, sine squared x. So here we have sine x multiplied by negative sine x, it's negative sine squared x, plus here cosine squared x multiplied by cosine squared x is cosine squared x over sine squared x. Sorry, we have here minus, not plus. So it's negative sine squared x minus cosine squared x over sine squared x. Okay. So we are going to take negative as a factor here. It will be negative sine squared x plus cosine squared x over sine squared x. So it will be negative, you know, sine squared x plus cosine squared x is 1 over sine squared x. And this is equal to what? 1 over sine squared x is, it will be equal to negative cosec squared x. So here the derivative of cot x is equal to negative cosec squared x. That's it. If y equals cosec x, find dy over dx. We can write, instead of cosec x, we can write 1 over sine x, and then we are going to apply the quotient rule, which is the denominator sine x multiplied by the derivative of the top 0 minus the top 1 multiplied by the derivative of the bottom. The derivative of sine x is cosine x over sine squared x. So sine x times 0 is equal to 0, and here minus cosine x over sine squared x. So we'll end up with negative cosine x over. We can write, instead of sine squared x, we can write sine x multiplied by 1 over sine x. You know, negative cosine x over sine x is equal to negative tan x, negative cotan x, negative cotan x, multiplied by 1 over sine x is cosec x. So the derivative of y equals cosec x, the derivative of this function, is equal to negative cosec x, write it as it, negative cosec x multiplied by cotan x. The derivative of cosec x is negative cosec x cotan x. Just to remember, write negative and then write the original function cosec x multiplied by cotan x. That's it. If y is equal to sec x, find dy over dx. We can write, instead of sec, 1 over cosine x, then apply the quotient rule. Dy over dx is equal to the denominator cosine x multiplied by the derivative of the top, it's 0, minus the top 1. So just to remember, down derivative top, down derivative up, minus up derivative down, minus up derivative down, over down squared. So we have up and down. So what is the derivative here? It's down derivative up, minus up derivative down, over down squared. So here it's minus 1 minus up multiplied by the derivative of cosine x. The derivative of cosine is negative sine x, all over cosine squared x. Cosine x multiplied by 0 is 0, and here we have negative multiplied by negative, it's a positive. So it will be sine x over cosine squared x. We can tie it up and write it as 1 over cosine x multiplied by sine x over cosine x. Okay, 1 over cosine x is equal to what? 1 over cosine x, yes, it's a sec x, multiplied by sine x over cosine x, it's a 10x. So the derivative of sec x is equal to what? Write it as it, just to remember, sec x multiplied by 10x. Let's go to the example, y equals sine 5x plus 1. We will use the chain rule. You know the chain rule, if we want to find dy over dx, it will be dy over d. We can write in a letter like dt multiplied by dt over dx, or dy over dz multiplied by dz over dx. So here we can write it as y equals sine t, and t is equal to 5x plus 1. Here we can find the dt over dx. dt over dx equals 5. And here dy over dt is equal to the derivative of sine is cosine, so it's cosine t. Okay, So what about dy over dx? dy over dx is equal to dy over dt multiplied by dt over dx. And dy over dt, it's a cosine t. So we can write instead of that cosine, and we will write instead of t, it's 5x plus 1 multiplied by dy over dx, which is 5. So we can write it as 5 cosine 5x plus 1. It's the derivative of the function multiplied by the derivative of what is written here in this bracket, the angle, the derivative of the angle. So dy over dx is equal to 5 cosine 5x plus 1. If y equals 3 cosine x squared plus 5, I want to get dy over dx. So here in this example, to get dy over dx, we can write it as y is equal to 3 cosine t, as we did in the previous example. And t is equal to x squared plus 5. Now we can find dy dt over dx. dt over dx is equal to 2x. And we can find dy over dt here. dy over dt is equal to, write 3 as it, and the derivative of cosine is negative sine t. So we can write it as negative 3 sine t. So dy over dx is equal to dy over dt multiplied by dt over dx. And dy over dt is equal to negative 3 sine t multiplied by dt over dx, which is 2x. We can write instead of t, we can write the original function x squared plus 5, as we assumed that t is equal to x squared plus 5. So here dy over dx is equal to 2x multiplied by negative 3 sine. And we can write instead of t x squared plus 5. Here it's instead of t. So we can tidy it up. It's 2x multiplied by negative 3, so it will be negative 6x sine x squared plus 5. We can do it quickly. If we have a function like y equals 3 cosine x squared plus 5. Find the derivative of the original function. The original function, 3 cosine squared x squared plus 5. We deal with it as a whole chunk, so it will be negative 3 sine x squared plus 5. Then multiply by the derivative of x squared plus 5, which is 2x. Tied it up, it will be negative 6x sine x squared plus 5. That's it. Let's go to the next example. If y equals sine to the power of 3 5x minus 2, we can write it as y equals sine 5x minus 2 all to the power of 3. So here in this case, we can write it as y equals sine t all to the power of 3. And t is equal to 5x minus 2. Or instead of that, we can find the derivative of the function directly. The derivative, it's 3, and here we are dealing with it as a whole function. So it's a sine 5x minus 2 all to the power of 2 multiplied by the derivative, what inside the bracket here. So it will be 5. The derivative of this function, 5x minus 2 is 5. We can tidy it up. It will be 3. Sorry, we made a mistake. We forget to multiply by here the derivative of sine 5x minus 2. So once again, it's 3 multiplied by sine 5x minus 2 all to the power of 2 multiplied by the derivative of sine 5x minus 2. The derivative of sine x minus 2 is cosine 5x minus 2, and then multiplied by the derivative of the bracket. Here it's 5. So we'll end up with 15, and then we'll write sine squared 5x minus 2 multiplied by cosine 5x minus 2. That's it. Here in this example, y equals cosine to the power of 4 6x minus 1. We can write it as cosine 6x minus 1 all raised to the power of 4. And pay attention. We're going to find the first derivative, so we will deal with it as a whole chunk, a whole function, so it will be 4, the power rule, and you write what is written here. It's a cosine 6x minus 1 all raised to the power of 3 multiplied by the derivative of cosine. Cosine 6x minus 1, its derivative is negative sine here, and write 6x minus 1 multiplied by the derivative of this angle 6x minus 1, the derivative of what inside the bracket. So it will be multiplied by 6. Tied it up, it will be positive 4 multiplied by negative multiplied by positive, so it's negative 24. And then cosine 6x minus 1 all raised to the power of 3, we can write it as cosine to the power of 3 6x minus 1 multiplied by sine 6x minus 1. So in this session, we have deduced the rule. And in the next session, we're going to answer some complicated questions on this lesson. So try to study it well, and see you in the coming episode. Goodbye.